All right, guys. Very good morning, very good evening. Hope you guys can hear my voice. Can anyone confirm?
Yes.
Yes, sir, definitely. I'm good.
All right, great. Let's continue with the yesterday's session. These are the two demo session as I stated. Yesterday we covered a couple of things. We just recap it today, and then we'll continue further discussion on those, the rack architecture and networking part. So yesterday we started with the introduction about a trainer, that's me, and I told about my journey and my areas of expertise and how many years of experience and which all organization I worked. That's about me I covered. And we started with the understanding of the course curriculum, what is there, what all it contains. So we went ahead with the what are the topics included in this course, and if there's any custom topics or extra topics that can be taken at the end of the course. And then we started with understanding of the course duration and course timing, fee structure. So everything is again explained in detail. So today is the last demo session. Yesterday we taken one, and today is the one more session. And about the course start timing. So next weekend, that's 20th April, we're going to start the actual classes. So the timing is 4 hours on weekend. Since this is a weekend batch, Saturday, Sunday only. So Saturday 4 hours and Sunday 4 hours, 4 hours of each. So we'll start it on 20th April, and probably with 5 weekends, we will be able to complete this course. And the course fee is 15,185 US dollar, and it will be of live Zoom session. And we are going to cover 19C version. So it will be based upon 19C Oracle version. So with that, we understood about the minimum requirement. So you should have a basic knowledge on Windows, Linux, and SQLs and database. If you don't have these, then this course is going to be little difficult. You will not be able to understand and catch up the things on the fly. So and then the minimum hardware requirement or the laptop or desktop requirement is you should have a 20 GB RAM and 150 GB SSD hard disk so that you can set up your lab for any practice. If you don't have a proper hardware or lab setup, then you will not be able to do a hands-on lab exercise. So you should be able to you should be able to listen and then see what I'm showing the demo. But in order to do you to hands-on, you should have a proper hardware setup and do a lab setup first. Right. So with that, that's about the course fees and the timings, what we discussed. And after that, we discussed about the communication through WhatsApp group. Like we have a dedicated WhatsApp group for each batch. All the communications, issues, queries, or whatever even not related to this particular course, even if you have any challenges or issues with your current organization, any particular task you are stuck and unable to proceed further, feel free to post all those questions in our WhatsApp group. Or even any one of you guys attended any interview and there are some challenging questions, feel free to share in that WhatsApp group so that benefited to other guys as well. And couple of questions around the Google Drive access and the Google Link access and the shared drive access, about the recordings, about the course materials, course PPT. So these are like lifetime accessible, available on the Google Drive. You can access it lifetime. And those Google Drive contains current ongoing batch recording, previous batch recordings, course PPT, workbook, and lab exercise, all the softwares, whatever needed, everything will be there in the Google Drive. Even you can download those Google Drive, uh, whatever the recordings, whatever the softwares, whatever the workbook, PPT, lab exercise, even you can download it locally into your laptop, no restriction on that. So since these are like lifetime accessible materials, whether you can download it or keep it in the Google Drive, doesn't matter. Right, so that is about the deep, discussion what we understood about the course duration, course timing, and how the structure of this course is formed. Followed by started with some discussion on the few concepts, rack architecture, networking, and how the software we are going to install it. And we discussed about the networking, public IPs, VIPs, how the failover happens. And we discussed about the advantages of standalone versus rack, why rack, and then what are the advantages of that. Right, so we'll continue further on that. So we'll go further deep dive and then understand few more concepts in the rack. So before that, if anyone has any questions or queries, I'm happy to take for a minute. So for whatever we covered till yesterday until now about anything on the course duration, timing, fee structure, or any of the WhatsApp or Google Drive access, or any of the concept what we covered so far on the rack architecture or the networking. Anyone has any questions? Right. Okay, so let's continue. We're going to talk about furthermore one of the common questions. Let's take a two-node rack. Two-node rack. How many IP addresses are needed? Let's take simple question. So I want to configure two-node rack. How many IP addresses are needed? Generic questions. So let's understand. So I'm gonna set up one two-node lab, lab one, lab two. So lab one, this is my node one and my node two, two nodes. And the default will be having one public IP. Let's say public IP, I'm going to take it 192.168.1.101. Then let's say node1 dot local domain.com. So my public node one having a node1 dot local domain.com, and then it has a public IP address 192.168.1.101. And then I have a VIP address, let's say 192.168.1.103. Node 1 hyphen VIP dot local domain.com. So again, for the node 1, we have private IP, let's say 192.168.2.101. Node 1 private dot local domain.com. Right, so these are my node 1 specific IP addresses. Same thing goes for my node 2 as well. 192.168.1.102. VIP is 192.168.1.104. And node 2 localdomain.com, node 2 VIP localdomain.com, 192.168.2.102, node 2 private.localdomain.com. So these are the three minimum IPs needed on each nodes for any rack setup. So this a public IP is for the node. Whatever this public IP is for the node. In order to set up any node, any server, that should have a physical IP associated to that particular node. And then this VIP is for any failure. If any client connected to my node 1, if node 1 goes down, the VIP will fail over, so that this client will be the connection will be carried to your other nodes. So VIP is very, very helpful for in case of any failure situation. Same thing goes for any client connected to my node 2. If the node 2 goes down, this VIP will fail over to other nodes. So VIP is basically meant for your failover operations. And then we have this private IP. Private IP is for node to node communication. Node 1 will communicate to node 2. Node 2 will communicate to node 1. The node 1 will ping node 2. Are you still available? Are you still alive? The node 1 will say, yes, I'm alive. How about you? Then node 1 will respond back, okay, I'm also alive. So node 1 and node 2, like you have 4 node RAC cluster, all the 4 node will communicate each other and make sure that all are alive and all are part of the same cluster. So node to node communication will uses my private network, and VIPs are very useful for my the failover situation. And public IPs are any server you set up, so that IP public IP will be associated to an interface, which is like your whatever the interface you have it on the lab or the server, that interface or the physical IP or the host name or the server are all one and same. So each node should have its own public IP where publicly can be accessed using that IP. So now 3 nodes, 3 IPs for node 1, 3 IPs for node 2, 6 IPs are needed. And then we have something called a scan. The scan is one more concept for the load balancing. Any clients want to connect, client one want to connect to my database, so it has to go to scan. Via scan is going to route intelligently whether to route the connection to node 1 or whether route the connection to node 2. Scan knows what is the load on this particular node 1, what's the load on this particular node 2, how busy is that. So if the node 1 is, like, let's say node 1 having 100 connections and node 2 having 50 connections, and node 1 is, let's say, around 70% is loaded and node 2 is like around 50% is loaded. So whatever the client 1 connection comes, so scan will route it to second node. Client 2 connection comes, scan will route to second node, and client 3 connection will comes and scan will route to second node. So scan is one of the intelligent feature is to analyze all the cluster nodes, what is the load currently available, how many users are connected, and based upon that, whatever the incoming connection, route those traffic to whatever the least loaded cluster node, so that it's going to match the whatever the load, 70% and 70% load is matching. So once it is matches, then whatever the new connection comes, scan will route it to either node 1 or node 2. It's kind of an intelligent mechanism internally how scan knows. But again, one of the common questions you may get it, how on what basis my scan knows my node in having 70% load, my node 2 having 50% load, right? That's one of the maybe you can expect in the interview questions. So that is because of the PMON process of whatever the database running on that node, PMON process will register the how many users are connected, what's the load, all those details into my scan. Because of that, communication of your scan with the PMON will able to identify what's the load and then how to route the traffic based upon the load. Right. So the question is the how many IPs this particular scan will be having. The scan will be having a default one, like you can default is 3, like best practice or default. You should have a 3 IPs for your scan. 192.168.1 dot. I have this 101 here, 102 here, 103, 104. Then I'll go with the 192, 168, 1 dot, 105, 106, 107. So a default or the best practice is to have a 3 scan IPs, but even you can go with one single scan IP, that also works fine. So in simple layman term, we need a 3 IPs for node 1, 3 IPs for node 2 mandatorily, and then 1 IP for your scan. So 7 with the 7 IP, you can able to do your lab setup or your rack setup. 7 IPs is a minimum IP needed, or if you go with the best practice, it should be 9 IPs for a best practice. So even you can go with your scan name with the 5 IPs, 6 IPs, 7 IPs, 8 IPs. There's no limit at all, right? 7 IPs is a bare minimum needed in order to set up a 2 node rack. 9 IPs for the best practice, considering your scan is having 3 IPs, node 1, 3 IPs, node 2, 3 IPs, right? So, and then further questions, that's your how many IPs are needed. How many physical IPs? How many VIPs? So your public IP and your private IP. Public IPs, private IPs, or physical IPs. So whatever we are seeing here, a public IP and a private IP, public IP and private IP. So these are your physical IPs. So how many physical IPs are needed? So it all depending upon how many nodes you have it. Each node, 2 physical IPs are needed. So 2 from node 1, one public IP, one private IP, and 2 from node 1, one public IP, private IP. 4 IPs, we need it as a physical IP. How many VIPs? Your node VIPs, your scan IPs. Node VIPs and scan IPs are your VIPs. So node 1 and node 2, we have 2 VIPs, and scan as a best practice, we're going to go with the 3 IPs. 3 plus 2, 5 IPs. Those are VIPs. Again, the question comes here, what is physical IP? What is VIP? Any IP assigned to a interface. Any IP tagged to a interface. The simple definition for your physical IP, the simple definition for your scan IP, any IP assigned to an interface. Like interface you might see in any of the server, ETH 0 or ETH1, or based upon your Linux version, you can see the different interface. So any IP is assigned to this interface, those are your physical IPs. Or any IPs tagged to interface, those are your VIPs. What that meaning, if I go to my server here, lab 1, if I do ifconfig on that lab, so this is my one of the interface. Node 1, node 2. So node 1, I have interface 1, ENS 192. I have interface 2. Same thing for my node 2 as well. Interface 1, interface 2. If I go to node 2 and do ifconfig, I can see ENS 192 colon. This is one of the interface. ENS 224 colon. That's the other interface. Interface 1 and 2, interface 1 and 2. Two interface on node 1 and 2 interface on node 2. So in this interface, we have assigned the IP address on node 1. And then in this interface, I have assigned the IP address 4.182, 9.182. If I go to second node, ENS 192, I have one more IP address assignment here. And I have ENS 224, one more IP address assignment here. The 4.182, 4.183. So these are your physical IPs and on the subnet called 4 series. In our lab here, 1 series, 1 series, 101, 102, those are your public IPs. Public IPs and the private IPs are the physical IPs. Physical IPs meaning attached to an interface. In this lab here, I can see one interface and second interface. Both these interface are assigned with these IPs. So those are your physical IPs. One is your public IP and one is your private IP. Public IP is for the node access outside your DBAs or client can access using that public IP, and private IP is for node to node communication. It's on node 1. Similarly for your node 2. Similarly for your node 1, again you have public IP assigned to this interface and you have this private IP assigned to this interface. Fair enough. So we got a clear idea now what exactly meaning of a public IP. A public IP is a IP assigned to an interface. You might have multiple interfaces in your Linux server. Just do ifconfig and you see any IP is assigned, then that's a physical IP assigned to that interface. And VIPs, VIPs are tagged to an interface where your physical IPs are assigned. Right? So VIPs are the IPs which are tagged to interface, not assigned to interface. Tagged in the sense, let's say I have this node 1 and node 2. We identified public IPs and private IPs. Now we can identify remaining VIPs and scan IPs. Because your VIP is also VIP, node VIP is also VIPs, your scan IP is also your VIPs. So we have 5 VIPs. So we can identify in the same pattern here. If I do on the node 1 ifconfig, so whatever this ENS 192, I have same ENS 192, ENS 192. So these are not your actual interfaces. Your actual interface is this one without any tagging. So but whereas here ENS 192, I have :1, ENS 192, :2. So that is your VIPs tagged to your public interface here, public IP, because your VIPs are in the same range of your public IPs. The question here is, this is one of my VIP. This is one of my VIP. These two VIPs are tagged to this ENS 192 interface. For this interface, :1, :2. Two interfaces, two IPs, two VIPs are tagged to this interface. Why these VIPs are tagged to this interface? Why it did not tag to this interface? Because your VIPs are in the 4 series. 4 series. Which interface is in the 4 series? Your ENS 192 is in this 4 series. So whichever interface in the same range of that VIP IP range, so your VIP 1, VIP 2, these two VIPs are in the range of this ENS 192 IP address. So because of that, :1, :2, two IPs are tagged. Now I identified two IPs here on my node 1, this one and then this one. Two IPs are tagged to this particular node 1. Similarly, from the other node, I have this ENS 192 :1, :3, :5. I have three IPs here. Right, so we got five IPs. As per our definition, how many IPs are needed? Node VIPs 2 and scan IPs 3. So those are VIPs can run on any of the cluster node. All the five can run it on one cluster node. All the five can run it on second cluster node, or all the five IPs are distributed on node 1 and node 2. Doesn't matter because VIPs are just IPs floating in your cluster. It may run on any of the node. So now out of these five IPs, we know that two IPs are node specific IPs, node 1 and node 2 IPs, and two IPs are my scan IPs. So once we identified this, that's more than enough for us. So later we have some cluster commands, srctl config scan, srctl config node VIPs, then we're able to identify it. But as long as you're able to identify what is your physical IPs, which are like private IPs and public IPs, and what are your VIPs, then that is our primary understanding how my rack cluster is set up. Right. So now like again we'll cover in basically in our actual class. Now if I give one command, so if I do srctl config scan, then it's going to tell me 192, 197, and 196. I have three scan. So looking at this one, 192. 192 is here. This is my scan 1. So and then 197. 197 is here, and this is my scan 2. And then 196. 196 is here, my scan 3. So I'm able to identify scan 1, scan 2, and scan 3. Three scan VIPs. And remaining all 190 and 191 are my node IPs, node VIPs. And then this is my node 1 VIP. Again, we have a command srctl config node 1 VIP. So node 1 VIP, and then this is my node 2 VIP. Right. So with the help of just ifconfig output, I'm able to identify what are my physical IPs, what are my private IPs, and what are my scan IPs. Right. Once you identify, like let's say, as I said, these VIPs, whether the node VIP or the scan VIPs or the VIPs, totally we have five, and these VIPs can run all in one single node, or all can run it on node 1 or node 2, or all distributed across both the nodes. Right now, out of these five, two IPs are running on node 1 and three IPs are running on node 2. Suppose your cluster is down on node 1 or on node 2, or your server itself is rebooted. Let's say SM1 crctl stat resource -t. So let's understand here. We have node 1 VIP, node 2 VIP, which is running on node 1 and node 2. Fair enough. I have my scan 1, scan 2, scan 3. Three scan VIPs running on node 1, like this one and this one. Two VIPs running on node 1. And remaining my node 2, node 2, node 2. Three VIPs are running under node 2. That's what we just identified here. Three IPs on node 2 and two IPs on node 1. Right now I'm gonna shut down my node 1. I'm gonna stop my node 1. I'm gonna completely shut down my cluster on node 1. The moment I do shut down on node 1, these two IPs will be failover to your node 2. And now all the five VIPs will run under node 2. Let's go to node 2 and run the same command. CRSCTL stat resource -T. So let's look at here. Node 1 VIP, Node 2 VIP, both are running on Node 2. My scan 1, scan 2, scan 3, all the three IPs are running under your Node 2. So now all the five, 2 plus 3, all the five IPs are failed over to your Node 2. And you can identify with ifconfig output as well. So here, when I ran ifconfig, it has this interface 192:1, :3, and :5. If I do the same ifconfig output now, 192 interface, :1, :2, :3, :4, :5. So all the five VIPs which are failed over into node 2 all are tagged into your physical interface here, NS192. Right, that is your IP address or IP requirement, and then how your VIPs behave in comparison with your public IPs or the private IPs. Right, any questions so far on this networking or the IP requirement?
Malik, Malik, I have a confusion here, as you have told already. So node 1 and node 2 is having one VIP, right? So it is basically used for failover.
Right.
So confusion is here, if all the VIPs are running in one single node and
Right.
second node is down, so how the failover will happen?
All the VIPs are running on,
One node,
right now it is running on one node. Right now it is all running on second node.
right?
Right. If the second node goes down, all will go to node 1.
No, my question is VIP is used for failover, right?
Right.
So means one VIP is for one node and second VIP is for node 2,
Second
right?
one, first node is failed over. First node is down now. Because of that, it moved to second node.
Yeah, got it that point. If both the node is running and
Both the
one
node is
VIP,
running, it will automatically distribute on all the nodes. The moment you bring this node 1 back online, automatically node 1 will VIP will come to node 1 now.
so it is not mandatory that one VIP is running in one node and other is running on separately on another node, right?
Right. You bring your
Thanks.
cluster back online, automatically node 1 VIP will come online here.
Okay, thank you.
Yeah, Malik, I think so. When our actually one node is shut down or crash any type of issue, so they will switch over to second node. Correct?
Right. Right.
Scan and VIP only. But what about the physical? I think the physical IP will not work because that
Physical
is the
IP, the meaning physical IP is a physical, means physically attached to interface.
correct.
If the server goes down, that IP will go down.
And what about the private IP?
Private IP also is a physical IP
Okay, okay, okay. So they will not switch over to another node. Correct?
because those are physical. They attach to that node, that interface.
Only virtual and scan IP will switch over to
Yeah.
another node.
Because virtual IPs and scan IPs are your VIPs. We
Oh,
think
okay. Got it. And scan IP work only for the distribute the load, correct?
right. That's correct. All right. So let's say now node is back online. CRSCTL stat resource -T. So now my node 1 VIP came back here. One of the scan also came back here. The moment your cluster nodes are online, all those VIPs will automatically distribute. Fair enough.
One last question, Malik. One last question,
Yep.
please.
Yeah.
For three node rack or four node rack, how many VIPs, scan VIPs are required as a best practice?
Best practice is always three. Whether you go with a 2 node, 4 node, 8 node, only three is the best practice. Even if you go with a 1 node, one VIP or 10 VIPs for the scan, doesn't matter. Three is the best practice.
Okay, thank you.
Again, like why these many IPs for the scan? So let's have only one scan. Again, there's a different concept in our actual class we'll discuss. So in just to answer your question, let's say I don't have these IPs. I have one scan IPs with a scan. Client 1 comes. Client 1 connects. My scan will route it for node 1 or node 2. Fair enough. Instead of that, instead of one VIP, one scan VIP, I have two scan VIP. I don't have third one. Client 1 comes. My scan will route either node 1 or node 2. That also works fine, no issues. And instead of 2, I'll have now 3. Client 1 comes. And my scan will route the connection to 1 or 2. Fair enough, that also works fine. Instead of that, 1 instead of 105, 106, 107, 108, 109, 110. So I have 6 IPs. Client 1 comes, scan will route the connection to node 1 or node 2. Fair enough, everything works fine. But why multiple IPs? Even with one IP, the behavior is remain same. Even with the two IPs, the scan job is to route the connection. Even if you have 6 IPs, scan will route the connection. Why multiple scan IPs are needed? So that is again one of the common entry question you can expect. Because of your HA, high availability. What is meaning high availability? Let's say client 1 comes, client 1 will be served with this IP. This client will get this 105 IP. With help of this 105 IP, he is going to get into node 1 or node 2. So for some reason, this IP is busy. 105 is busy or something wrong with the network side and this IP is not available. The client immediately get a response, unable to connect. And then client again has to enter his username and password, retry after some time. So to avoid that kind of a hiccup at the client side, so Oracle has came up with this multiple IP. So when client trying to connect and automatically going to get this 105 IP is not there or busy or something else, and 106 will be assigned it to client 2, client 1. And 106 is not there, then 107 will be assigned to client 1. If 107 also not available, busy, then client will get a response, unable to connect. So just to avoid that client side connection issue, Oracle has multiple IPs for the scan. It's kind of a high availability for your client connection. Otherwise, with the respect of one scan IP, two scan IP, three scan IP, the scan job is to distribute the load. Everything works fine. All right. So let's quickly talk on your two more concepts. One is cluster maintenance and database maintenance. Right, cluster maintenance means so I have node 1 and node 2. So I need to bring down my node 1 to check my cluster health and start my cluster health. So I'm going to run CRSCTL stop CRS or CRSCTL stop CRS -F, which is going to stop my cluster. This -F is a force option. If you try to do CRSCTL stop CRS, sometimes it may take longer time because of some process hang or taking a longer time to shut down. In that case, you can use -F. It's a forcefully shut down your cluster. So it's going to bring down all the services, resources, daemons, whatever running on that node. And then it's going to move all the IPs to your second node. CRSCTL start CRS. So it's going to bring all the service back online. So again, you might ask like, do I have option CRSCTL start CRS-F? No. There's the start, no force option. Only for the stop you can have force option. But the start, there's no such a force option here. It's just a CRSCTL start CRS. And then how can I quickly verify my cluster services are down or my cluster services are up? So here, one way to verify is CRSCTL. Check CRS. It says cluster service is not available, unable to connect. So this is your check CRS. or you can do ps-f grep d.bin. So the d.bin will give you all the OS level daemons associated to your cluster services. If I do the same thing on node 2, CRSETL check CRS, it says on the node 2, all the cluster high availability service, cluster ready service, synchronization service, your event manager, all are online. ps-f grep d.bin, all your cluster daemon at OS level, all are online. So quick way to check on the cluster side is check with the CRSETL check CRS or the d.bin. Then let's quickly go back and start your cluster which is down. Right now it is on down. Node 1, everything we brought it down. So you can go ahead and then do CRSETL start and the cluster will be back online. So this is an individual node. Node 1 or node 2, you want to do shutdown and startup, you can do it. So we have an option where you can do from the node 1, what is the status of my cluster on the other node. So CRSETL check cluster hyphen all. So whatever we are doing here, CRSETL check CRS on node 1. Right now your HA is online, your synchronization service is online. These two yet to come. And if I run the same command on the second node, CRSETL already it is start is already running. Should not have done that. So CRSETL check CRS on node 2, all the services are online. So but being at one single cluster node, I can check the all the cluster node by running this CRSETL check cluster all. Let's node 1 to come online. So right, node 1 is online, node 2 is online. If I run this check cluster all, which is going to give me all the node 1 and node 2 cluster status. Check cluster all, your node 1 all is online, node 2 all is online. So either you can run this command to check all the cluster nodes whether the service is up and running, or you can go to individual node and run this one CRSETL check CRS. We're going to give here CRSETL check CRS. We're going to give all the cluster daemon. Again, it's going to give only 4 services. If these 4 services are online, that indicates your all the cluster resources are online. So if you want to check all the cluster resource on that node 1, you're going to use CRSETL stat resource -t -init. So it's going to give only the cluster resource running on that node. So -init. So on node 2, these are the cluster resource running here. If I run on node 1, same thing on node 1, these are the cluster resource running on this node 1. So -init for only listing out all the cluster resource on node 1. This is your ASM instance, and this is your cluster interconnect. That's your basically a private IP address for the cluster node intercommunication, node 1 to node 2 communication. Cluster interconnect is your for private IP addresses. CRF is your cluster health monitor, and CRSD is a cluster ready service daemon. And again, we'll talk in our regular classes what is this CRSD and what's the use and what's the purpose. In the simple definition, CRSD or the full form of the CRSD is cluster ready service daemon. CSSD is your cluster synchronization service daemon. Again, we'll talk about CSSD and CSSD monitor, that is cluster synchronization service daemon. Like again, we have its own purpose and job. CTSSD is cluster time synchronization service daemon. So just to name itself indicates these two services will gonna maintain both the node to node synchronization, and this gonna maintain your time synchronization between node 1 and node 2. Your diskmon will be always offline. Diskmon will be used only in Exadata. For your on-premises, it will be not be used. It will be always offline. This is for your ACFS. If you're using ACFS file system, ACFS drivers will come. So otherwise, it will not be useful. EVMD, it's your event management daemon. So cluster node 1, node 2, all the communication messaging will be happened with your EVMD. GIPCD, your grid inter-process communication daemon. So that is again node to node or ASM to ASM, all the cluster node inter-node communication. GPNPD, grid plug and play daemon, and MDNST, it's a inter-node broadcast messaging, and storage is your shared storage between node 1 and node 2. So each of them has its own specific task, and we'll discuss more in our regular classes. So this is one command to verify how your cluster services running on node 1 and node 2. Same thing, if you go and then run it on node 2, will be same output. So if you just remove this init, you're gonna get your output from all the cluster nodes. If I remove this hyphen init, you're gonna get all my cluster resource from both the nodes and my local resource from the both the nodes. I have local resource, listener, database listener, CHAD, network, ONS, proxy ADVM on all the nodes, node 1 and node 2, and my cluster resource from node 1 and node 2. What's the issue? You can get it here. So whenever you work on any client, especially for the two node rack setup, it's a two node rack setup. I have node 1 and node 2, and you may eventually end up with seeing this OCR disk group 1 and 2, and it will be having this third instance details. RICO 1 and 2 and the third details. ASM instance 1, 2 and the third details. It says offline and not useful. Your ASM network 1 and 2 and the third one is here. So why this third one? It only available in 19C, 19C and what's in 12C. If you run the same command, you see only two node rack, only two entries. You don't see this third entries. But in 19C, you're seeing this one extra third entry, which is with offline. Even though I have only two nodes, but I'm having this third entries. That is because of in 19C, we have this flex ASM. Flex ASM, which is become mandatory in 19C because of that flex ASM. Flex ASM needs minimum you should have three ASM. Minimum you should have three nodes. Because of that restriction, you can see even though you have two nodes, it'll end up with creating this third entry, which is not useful. So you can ignore that safely. Whenever you see in any of the client for two node rack, you're seeing this third node entry, you can just ignore that. Or you have an option to remove that one, manual cleanup, but that's not needed. That is because of the flex ASM. Right, so this particular command, crctl stat resource -t, is going to give you all the cluster resources from across the various nodes. Right, so that is your how you can check your at high level your cluster resource services and daemons with -t -init. Right, those are your basics how you can deal with. And by looking at this one, what it says, your DB database offline and it is unable to start, stuck in archiver. So stuck in archiver meaning your database unable to generate archive log. Basically your FRA for your DB database got completely full. So right now your database is kind of a hang. Right now DB 2 here and node 1 it is completely down. Node 1 is not started at all. So only node 1 is completely down and node 2 your stuck archival meaning your database whatever that DB database which is stuck in archival. So I can quickly go and then delete all the archive log and it want to continue to work. DB2. So I'm going to connect to armand target slash. I'm going to delete all the archive logs. I don't need it. Unnecessarily those archive logs are filled up my FRA location. Because of that, now it is stuck. Delete archive log all. I'm going to delete all the archive logs associated to that DB database. Right, we have so many archive logs from March. Right now, once this is done, now my database will be back to healthy state. So I can quickly go to node 1, devdb1. Right now, all the archlogs got deleted. I can do srvctl status database -d devdb. So this is my first command to do any database maintenance. Status database, my devdb database. It says node 1 instance is not running, node 2 instance is running. So I can do stop my database to shut down my database on all the cluster nodes. Node 1, node 2, everything will be down because I'm using srvctl stop database and my database name. So it's kind of a complete downtime activity. So rather than, let's say, I have node 1, my devdb instance 1 is running here, my devdb instance 2 is running here. Typically what we do, we connect to instance 1 SQL plus /assist DBA and connect to your instance to SQL plus /assist DBA, shut immediate on node 1, shut immediate on node 2. So rather than running on node 1, node 2 shutdown command, what we are doing it directly, we're using srvctl to stop it. So if you have, assume you have 4 nodes, you have to connect to all the 4 nodes and connect SQL plus assist DBA and then do shut immediate. Rather than that, with the one single node, srvctl stop database, which is going to stop your database from all the nodes. Right, node 1 instance not running, node 2 instance not running. So again, you want to start your database on all the nodes. Start database, we're gonna start on all the nodes, irrespective of whether it has a 4 node, 8 node, it's gonna start it from all the nodes. Stop database. Right. Otherwise, if you don't do this start database, what happens? You have to connect to your node 1, start, you have to do startup. Connect to node 2, you have to do startup. Connect to node 3, do startup. Connect to node 4, do startup. You have to multiple times connect to those servers and do a startup, and you're gonna start your database instances on all those nodes. Status now, node 1 running on node 1, devdb instance 2 running on node 2. So it's up and running on all the nodes now. There's a situation now, you have to do instance maintenance. So I want to shut down only second instance. I want to shut down only first instance. For that also we can use srvctl. srvctl status instance -I, your instance name, devdb1 -d, your devdb. So you can do srvctl status instance. So it says devdb1 running on node 1. You can do the same thing for your status instance devdb2. devdb2 running on node 2. Same command, you can use it for shutting down. Stop instance 1 and 2. And you can do the same thing, start instance. Start instance, you're going to do that. So being on any one of the cluster nodes, right now you connected to node 1. From the node 1, you can shut down your node 3 instance or node 4 instance. Any one of that. Both will work. So right now I'm going to shut down my instance 2. Being at node 1, I'm going to do srvctl stop instance. What it says, service. Okay, it has a service. It is unable to stop my services. This database is configured with my RAC services, and you have to move those services first before you stop your database instance. Right. If I check for one more time, srvctl status. So now your devdb database is running on node 1, node 2. What I'm talking about, this services, DevDB failover service. We have the service, and in order to stop your instance, first you have to move that service. Once you move that service, and then you can stop your instance. Right now, your DevDB database, which is in open mode and working fine. Earlier, it was in a archival stuck state, and it was not operational. Your database is kind of a stuck archiver. It means because of FRA full, your database was in stuck state. Now your database is in healthy state, and anyone can connect and access your database. All right, so any questions so far on the cluster side or database side, how we can do this maintenance or the check?
Yeah, Malika, just like that, we don't want to give the database name. So how we can start and stop our RAC
How we
instance?
can stop and start?
Start and stop our.
For what?
Just like that, we don't want to use DevDB. Okay.
DevDB.
Instead of DevDB, we want to some another parameter that we can stop all the rack instance and start all the rack instance.
All the databases.
Yeah.
Yeah, you can do stop cluster all.
No. With the help of SR, only I'm talking about only database link, not a
But we don't
CRCT.
we don't have option. You have to shut down all the
We
databases one
have
by one.
now unique with dollar unique underscore database.
Unique underscore database, what?
Actually, we can give na command srvc tier stop stance -d and dollar unique underscore database. I think
Yeah,
so.
that is gonna be basically you're shutting down all the databases by passing
Correct.
your dollar parameter.
Yeah, just like that, you don't have any unique name or you don't have any database name, so you can use that v dollar unique underscore database.
Yeah, fine. Yeah, that is one of your scenario. You can test it out. But basically, either you can shut down your database or start your database, or shut down or start your instance. If to do any maintenance activity for your database level or instance level, or typically you can do a maintenance activity at your cluster level by shutting down your cluster. Great. So let's talk on one more topic and then we close it. Your file system structure. Right. File system structure. We talked yesterday a little bit. We basically any standard database will want to start with a SP file or P file and then followed by control file and your data files. In data files, like let's say in data file we have system, sysocs, we have undo, we have temp, and followed by we have alert log, trace, and incidents, dump, or whatever it is, TRM, and then before that, redo. So let's say these are your basic files needed for your database operation to diagnostic. So in case of RAC database, we have shared and non-shared files. Your SP file is shared in case of RAC. So meaning if I connect to DevDB, SQL plus as sysdba, show parameter SP file. So I have this data DevDB parameter file, SP file, devdb.ora. If I go to node 2, DevDB instance 2, show parameter SP file. So it will be same thing, dev data devdb parameter sp file devdb.ora. So your sp file is saved in case of your RAC database. Your p file is non-saved. So your p file will be individually inside Oracle home, DBS location, init devdb2.ora. So we have this init devdb2.ora on node 2 that is specific to this node 2. We have node 1 Oracle home DBS ll init devdb.ora. So this is my, oh, we don't have that one. We don't have here devdb1. Here it is devdb1.ora. So we have this devdb1 and devdb2. So both are non-saved. Each node has its own individual init fee file. And this is your saved one, which is available under your saved ASM disk group. Control file, again, shared one. So if I go to my node 1, select name from $, control file. So I can see 2 control files on node 1. So if I connect to my node 2 and run the same command, I can see the same 2 control files, which are saved. Same control files are saved between node 1 and node 2. Node 1 and node 2 can write and read same control file. System, select name from $, data file. So I have system, sysocs, users. Like this is my system, sysocs, users. Let's put over here. Users or any custom data files. So your system, sysocs, temp, users or any custom data file, all are saved except your undo. So your undo is here.
Undo and redo also?
I'm yet to explain about redo. Give me a second. Please stand by. So your undo has your undo TBS1, undo TBS2. So your node 1, instance 1 has its own undo TBS, instance 2 has its own undo TBS. Except your undo, all other data files, system, sysocs, users, or any custom data files are all saved. Your system is saved, your sysocs is saved, sysocs, and your temp is saved, and any custom or user data file is all saved. And temp, whenever, like you might be aware, like we cannot list the temp data files using $, data files. You have to use select name from $, temp file. Your temp is saved, sysocs, system, users, or any custom data file, whatever you create, all are saved, except your undo. Undo we have each instance specific. Because undo we are going to specify in our SP file or the P file. Node 1 has undo 1 and node 2 has undo 2. Because of that, we end up with creating 2 undo data files which are instance specific, not shared each other. And then redo is again, where is that one? Non-saved here. So your undo is non-saved and redo also is like non-saved. So if I do select member from VDLR log file, so we have redo group 1, redo group 2, redo group 3, redo group 4. I have 4 redo groups, and then 1 and 2 belongs to my instance 1, and 3 and 4 belongs to my instance 2. Instance 1 and 2, instance 2 has its own redo logs. So you can verify using describe VDollar log. So we have group number, comma, thread from VDollar log. So what it says, my group number 1 and 2, redo log group 1 and 2 belongs to thread 1. That is your instance 1. So your instance 1, the DevDB instance 1 has redo group 1 and 2. And your thread 2, that's your instance 2, DevDB instance 2 has redo group 3 and 4. So whatever in this a member log file list, we have this redo group 1 and 2. These 4 redo log files are belongs to my instance 1, and this 3 and 4 belongs to my instance 2. So your redos are again non-saved. Redo logs are non-saved, your undo is non-saved. Apart from that, all the other data files are saved. System sysocks, user, temp, and any custom data files. Your control files are saved, your SP file is saved, and P file is non-saved. But apart from that, whatever other files you can see, trace files, incidence files, dump files, TRM files, any diagnostic files are non-saved. Right? So any of the diagnostic files also non-saved, because each node 1 has instance 1, node 2 has instance 2. So if I go to my node 1 diagnostic file, U01 app, Oracle diag, RDBMS, your DB name, instance 1, trace. So we have node 1, a specific directory here. And if I go to node 2, node 2 has its own specific directory, U01 app, Oracle diag, RDBMS, DevDB, DevDB trace. So your instance specific DevDB1 and DevDB2. Instance 1 has its own particular directory, instance 2 has its own particular directory. If I do LL alert, so we have DevDB instance 1 specific alert here, LL alert. We have this DevDB instance 2 specific alert log. And along with that, if I do ls-ltr here, all the trace TRM files, node 2 has its own specific files, and node 1 has its own specific files. All the trace TRM diagnostic files, whatever, all are like node specific. So whatever you see diagnostic files, alert, trace, incidents, dump, TRM, or any diagnostic files are all non-saved. Those are like instance specific. Like your redo log is also instance specific. Your undo data file also instance specific. And your system sysocks and temp, any user or any custom data files are saved. Control files are saved between both instances. Your SP file is saved between both instances, but whereas P file is non-saved, it's instance specific. Right. Any questions here so far on the file system structure, how what is saved and what is non-saved?
Yeah. Malika, why they have not say undo and redo log file? Can you explain?
The instance user who is connected to instance 1, they're going to use their undo. The transaction will be saved on that redo logs. The user who are connected to instance 2, they'll generate their own undo or redo in that instance 2.
And why they are not using share? Because they also use share and do.
Again, as I mentioned, undo you're going to specify in the P file. That's the instance specific P file. Oracle home dbs cat init dev db1. So you are going to specify your undo in the P file. That's the instance specific. You're going to specify that redo threads in the P file. That's the instance specific. Your redo or undo, we are calling it out in the P file or the SP file. So Oracle is end up with creating its own specific undo and redo files for the instance specific. Right? It's nothing called we are if you don't define your undo in that P file, your instance will never start. Right.
Hi Malik, we know this side. So let's say it's a new server and we do not have any idea about the location of files, right? And database is down. So how do we find out the location of network files,
What
parameter files, and alert log files?
one single command, right? Like there are a lot of things. You want to find out your alert. Once you find out your alert, and then you can do most of the things.
It's a ASM configured file structure, right? And we want to
No,
find the
like
location of network files, and
what
database
network?
is down.
What network
Uh,
files?
Network files is TNS names dot aura and
TNS. Yeah.
yes.
So only first thing is you need to identify where is your alert log. Once you're able to identify where is your alert log file, then you can able to find out where are your other files. So either you can use Linux level find command, or you can use your locate command. Once you're able to identify where is your alert log and just grab few of the things in the alert log, and you can able to get it out where is your SP file, P file, what are your data file locations, and what's your Oracle home. Or you don't able to do this one, and you do cat your etc Oracle file. And the moment you do cat etc Oracle file, okay, I can see my DevDB running over here. Okay, once I'm able to find out my Oracle home, and then I can go to that respective network and TNS admin directories. Oracle home, network, admin. So then I can see all my listeners and TNS files for that one. Or if nobody added entry to your etc Oracle file, you can go with either use a find command to find your alert log. We know my database name is DevDB. I can go with the locate my alert DevDB instance 1.ora. So I got my alert log. Go into your database and search for your Oracle instance starting. So scroll further down, that's going to give you where is your SP file, what's your Oracle home. Your Oracle home is here, and which file it's going to use. It's going to use here P file. You have to go ahead and check for the last startup. This is I'm talking about first startup sequence. It is on 2023. You can go all the way down, or you can grab for this particular instance. So I'll go all the way down and then search for that keyword, Oracle starting Oracle instance, and scroll down. So now it says this is your Oracle home and this is your SP file, right? So there's no, if you don't have your inventory, you don't have proper management. So you have to go here and there and then search for details, whatever available. So I got my SP file, which is on data disk group. I got my control file, which is on data and records group. I can go and then start my database instance. Once I start my database instance in no mount, I can continue to find my data files and other things.
To go to this location,
Which location?
the SP file location that is available in the ASM.
That's your ASM disk group. You have to go to that particular location and then verify that. So that will be your plus data, devdb, and parameter file, ls -ltr. So this is your actual file what we created, and Oracle internally created a alias name for that. Right, and then we have control file one on data disk group here. So this is my one control file, data devdb control file. So again, this is my actual control one file, and Oracle has given an alias name for that. One
Can we
control
open the
file.
file here?
These are the binary files. We cannot open any of these
What
files.
is a P file? Can we open here?
Your ASM supports only binary files. Your ASM, whatever storing here, only binary files. You cannot put your text file, you cannot put your P file, you cannot put your any of the files. It supports only for your RMAN backups, your arclog files, your redo files, control files, data files. Only binary files is supported in ASM. No human readable text files supported in ASM.
Thank you, Malik. It's clear now.
Malika, archive also different, will be the same in the both instances.
Archive is out of the scope. Our archive is not related to your instance. If your redo log one, where is that one? Your redo log one generates one archive. Your redo log two generates two archive. Your redo log three generates three archive. Your redo log four generates your four archive. Archive logs will never come into picture for my database maintenance or administration. Right? So those are the copy of your redo logs. All right. So we
Malik,
understood about the
one
file
question.
system.
Malik, one question.
Yeah.
In above, we use the service detail status and we get the all the details from the all the nodes, correct? By using the DB name.
Great.
So like we have three nodes. So how we get the third node status in our like from in node one? Is any process work in back in the end? Like how does it happen? Or any
Again, we talked about so many things here, right? There are so many program or so many cluster resources which is gonna talk to each other. One is your, again, let's say, I don't have that slide to get it, okay, or else I can do this one. Again, that is a first basic. Let's say I can get one of my database slide. Okay, few of the background process I can talk about here. Let's check this one. I don't have that slide. Okay, there are a lot of background process, especially. Okay, let's get this slide here. So one thing, there is when you start with the file system database versus your ASM database. ASM database means your database is sitting under ASM. It may be RAC or standalone, doesn't matter. So there will be a lot of background process will get added. Especially one is your PZ9N. PZ9N is for your GV dollar instance, and ONNN, that is one or more ASM slave process forming a pool of connections for exchanging your messaging. So apart from that, there are so many other cluster level resources, CRSCTL, stat resource -t -init. So even here in this particular cluster resources, so very important process, we have GIPCD, I told you. That's a grid inter-process communication daemon. And then we talked about CRF, that's a cluster level health monitoring resource. And if we remove this hyphen init, and then we have CHAD, again cluster health monitoring daemon, and followed by we have, where is that other process? ONS, Oracle Notification Service. So all this process will help each other to communicate all the cluster nodes. And being at one node, you will be able to get the details from the other cluster nodes. Right? One example for inside database, if I talk, it may be ASM or it may be database. Let's go with the database only. Let's say I can say describe a GB dollar instance. Select your instance ID, instance number, instance name, and host name. From I'm gonna use first GB dollar or the V dollar. That's gonna give me only that local instance. Instance. Let's go with this one. I got instance number 1, instance name running on host 1. Instead of V dollar, if I use GB dollar, so that's gonna give me both the nodes. So this GB dollar background process helps because of one extra background process came here, PZ9N. So that is helpful for your GB dollar views. Similarly, when you run your cluster level command, crctl, srvctl, status, database -d, devdb. So it's a cluster level, your cluster level resource, which is gonna help you to get all your database status. So that cluster level resource internally uses same GB dollar views to get your instance status. Right? That is all your how cluster is formed. If you don't have a cluster communication, and then you don't have option to get those details. Right? Very first thing, your cluster resource daemon is your CRSD. Your CRSD is the main cluster resource daemon, which is gonna helpful for keeping your both the node 1 and node 2 communication healthy. If any of the node is not able to communicate or not able to like respond each other, I have node 1, node 2, this node 1 and node 2. Node 1 I have CRSD, and node 2 also have CRSD, which is a very critical resource, which is going to make sure that all the clusters are healthy and then talking each other. If the node 1 is not talking to node 2 is not talking to node 1, then your synchronization service daemon will come into picture. Node 1 will send it to node 2 is not sending any response. Then node 2 will be evicted by with help of this CSSD, cluster synchronization service daemon. So these are your cluster services, which is going to helpful for your all the cluster level communication, whatever CSRVCTL or CRCTL command we're running it. So those cluster services internally uses your GB dollar views, whatever we're running here, and then get those actual status of your instance and database. Right?
Basically means both the background process and the cluster level that daemons help to each other to
Right.
get this.
That's correct. All right. So yeah, let's wrap it up today. I don't want to continue any further topics. It's too much for everyone. If anyone has any questions or queries, I'm happy to take it up. Otherwise, we can wrap it up for today. All right. Anyone so far or any concerns or queries?
When you will start this match?
Coming Sunday, coming Saturday.
Coming Saturday. Okay.
Yeah.
Around you can say in 20 of April, correct?
Yeah.
Okay.
All right, guys. If no question, just wrap it up. Happy weekend, and we'll connect on our coming actual classes on Saturday.
Thank you, Malik.
Thank you,
Malik.
Malik.
Thank you all. Bye.